Hello, my name is Austin. I'm the planetarium operator and STEM educator here at Ella Sharp Museum. And today we are doing our virtual Romance in the Stars, our Valentine's Day program, where we'll sort of travel through mythology and history and space, seeing where romance and astronomy connect. And I think there's lots of really cool stories that do connect these two. Following that, we'll be doing a little bit of a night sky tour, but the night sky tour is special because it's sort of about someone's anniversary, which is part of our show. We take requests in the show for like a night sky tour of someone's specific anniversary date, something special to them. And then at the end, we'll do a little bit of a universe tour where I can show you some of the cool stuff in the universe. We'll sort of travel to the edges of time, everything observed by our big telescopes. It's cool stuff like that. So we'll get started. I'm going to share my screen over to the sky. So what you should be seeing right now is a view of the sky. It's sort of our planetarium view where you can see the whole sky at once. It's all kind of crunched down like that. And from here, we can begin to think about stories. So humans, us all, all the people on Earth and all the time we've been here, we're pretty good at telling stories, and we have a unique talent for finding ways to tell those stories. So stories can be told through music, sculpture, paint, literature, and film. But one of the first ways to tell stories was through the night sky. So let's speed up time. We'll set the sun over in the southwest, and we'll check out the night sky view. So as the sun sets, you're going to start to see a lot of stars come out, maybe some familiar constellations and characters, but a pretty busy sky. This is the sky, without a lot of light pollution, of course, so you may have to go out in the country to see a sky like this. But if you imagine yourself back in time, you can think of, staring up at the night sky and over time connecting the dots and creating these shapes. And then back in the day, people would use these shapes to record their beliefs, their mythical and moral beliefs, but also their beliefs about love. And so the constellations we are currently looking at are the Greco-Roman constellations, mostly. A lot of the constellations developed a couple thousand years ago through the Greek and Roman astronomies. And the characters they created through that, you can see some animals, people, objects. Some of the objects are actually some newer constellations from only the past couple hundred years, but pretty much everything we're seeing here has some sort of Greco-Roman history to it. Now, one of the important parts in the Greco-Roman mythology is sort of in front of us down to the south. So I'm going to kind of zoom in to give us a view right over here. And you might already recognize this constellation we're looking at. It's Orion. So Orion is one of the oldest constellations in the night sky, under different names, with some interpretations dating back to Babylonia. Throughout history, Orion has been part of many stories as a warrior, a farmer, and a hunter, and that's what we know him as now. Mythologically speaking, Orion is a mortal giant hunter. So this is a human like us, but very tall. He was born of one of the Gorgons, a sister to Medusa. And he hunts across the wintertime night sky with the help of his hunting dogs, Canis Major, the big dog, and Canis Minor, the little dog. Now, one of Orion's most famous stories, some of his most famous stories, come from different hunts. So he hunts Taurus the bull, or he hunts Lepus the rabbit. But in some stories, he's hunting for love. And that's where we'll sort of connect it here today. One of his most famous romances was with the huntress god, Artemis. So Artemis, one of the important deities, a pantheon deity in Greek mythology. As a great hunters, they fell in love through this connection. However, Artemis was a very high-ranking Greek deity, and for deigning to love a mortal like Orion, Artemis's brother, Apollo, tricks her. He places Orion way out in the Mediterranean, and he bets that Artemis can't hit that distant object with one of her arrows, which she is a very good archer. And of course, she did hit Orion and he died, and that was the end of him. Now, other stories of Orion relate him to other characters in this very part of the sky. So we can point out the constellation of Taurus, this sort of V shape just above Orion, and just across from Taurus lives the Pleiades. The Pleiades, 7 sisters, daughters of the Titan Atlas. They're all like sort of giants, but they're immortal giants. So Orion is a mortal giant, a human like us, and these are immortal giants, sort of a higher level of being to the Greeks. And again, it wasn't really a good thing. It was kind of looked down upon if immortals or the higher deities fell in love with mortals. Now, it happened all the time, and they usually punished them for it, but this is another one of those. The Pleiades, the 7 sisters, can be seen in the sky above Orion because Orion's a mortal giant. The Pleiades are giants, and so he likes the tall ladies, and he fell in love with them and pursued after them. Zeus said that's a big no-no, so he plucked them from their positions and placed them in the night sky so that Orion would forever chase the Pleiades through the winter. So just past Taurus are these little groups of stars called a star cluster. And that star cluster is the Pleiades. Looking at it up close, you can see it's packed with beautiful blue stars and dozens of other bluish white stars and white stars. It's a star cluster, so they're all born together and they travel through space as a group. And Orion chases these through each winter night. Another part of the sky, we're going to back out to get a better view. I'm going to do the whole planetarium view again. Is in a different part of the sky. In order to see it better, we're going to go a little bit earlier in the night. Up here near the top, we have a handful of constellations that are part of the Perseus and Andromeda story. You may have seen this story through movies or books, sometimes comics. It's a very prevalent story, but here we can see it in one of its original forms in the night sky. We have Cassiopeia, the queen, a mythological Greek queen from prehistory. Her husband, Cepheus. He doesn't make a ton of appearances in this story, besides he helped Cassiopeia make a daughter named Andromeda. And Cassiopeia believed Andromeda to be the most beautiful woman in the whole world, even more beautiful than the sea nymphs of the god Poseidon. And this angered Poseidon, as the Greek gods are very jealous types. And so he chained Andromeda to a stone by the sea and sent a great monster after her named Cetus. And in some depictions, Cetus is a great whale, but in this story and over time, kind of is often depicted as this weird dog mermaid creature. So kind of strange. Now, of course, there's a hero to this story. It's one of those classical hero love romance stories where Perseus, just returning from defeating the Gorgon Medusa, he took her head and he made friends with the winged horse Pegasus, who's sort of diving below the horizon in this view. And together, Pegasus and Perseus save Andromeda from the monster. They release her from her chains, Pegasus flies her away, and Perseus uses the head of Medusa to turn Cetus into stone, saving the princess and falling in love. Very traditional story, but it's kind of neat to see it in its original interpretation in the night sky. We're going to change our view to the October sky, sort of a fall time sky. And here we can talk about a little bit of crossover between reality and the night sky and the constellations. So back in the day, Greek astronomy was hugely important to Roman astronomy, with a lot of one-to-one crossover of celestial deities. Greek gods like Hermes were also known as Mercury in Rome. Aphrodite is Venus, and Jupiter is Zeus. So there's a lot of crossover, and there was differences as well. But nearly 2,000 years ago, Hadrian became the emperor of Rome, became Emperor Hadrian. after the death of his uncle Trajan. Throughout his life, Hadrian was fascinated by Greek mythology and their stories in the sky. We can see a little bit of a sort of a bust of Hadrian here. And it's important to remember that his fascination with these Greek sky stories was similar to the Greeks in that they weren't just sky stories. There was a lot of legend and history, almost a prehistory in the beliefs about these sky stories. So they were very important. And as a Roman emperor, Hadrian was sort of elevated to a semi-divine status. So Roman emperors were considered semi-divine. And I think he felt closer to these Greek mythologies now that he was at such a high level. Now, Hadrian didn't just love ancient Greece, he also loved one of his servants, Antinous. And they traveled across Greece for years. They were inseparable. They visited temples and cultural sites and art and like the different Greek festivals. They loved all of that. And they traveled, by boat across the rivers and the sea until eventually an oracle predicted that Hadrian would perish and die or not be emperor anymore if he didn't lose the thing that mattered to him most. And a lot of people interpreted this as Antinous. Some stories say they picked Antinous and threw him in the water. Some stories say Antinous threw himself in the water, all to save the rule of Emperor Hadrian. And this made Hadrian very depressed because his lover was dead. And so he used his powers as a Roman emperor to elevate Antinous to a divine status by creating a constellation. The location of this constellation is near the constellation of Aquila. So along the sort of the Milky Way in the sky, you can find a set of stars that kind of looks like a stingray or a kite or maybe a bow and arrow. But this is known as Aquila the Eagle, which just means eagle the eagle. And they placed Antinous about right there. So if you drew out the eagle, this little space below the eagle, those stars were made up to be a constellation of a real person that lived about 2,000 years ago. And he persisted as a constellation for a couple thousand years until a lot of the constellations were sort of reduced and simplified. But those same stars can be seen in the sky. And it's kind of neat to know that for a long time, they were culturally representing a specific person in history. Now we can sort of flip it. We talked about how, history met the night sky. We can kind of see where space meets the mythology, and we'll go to Jupiter, the planet Jupiter. So here on Jupiter, and we're gonna change our view again so we have a little more flat view of it. Here we go. Jupiter is the biggest planet in the solar system. As of now, I believe we have 79 moons detected around Jupiter, and they expect to find hundreds more as we look more and more. The biggest of these moons, called the Galilean moons, which were discovered by Galileo Galilei in 1609 when he first pointed a telescope at Jupiter. And then, a man of history, Galileo named these moons after some of the fated, unfortunate lovers of Zeus. As we said before, it was sort of looked down upon for an immortal and a mortal to be together, but that never stopped a lot of the Greek gods from falling in love with mortals anyway. And Zeus was one of the more common ones. You can find the names of his lovers on moons like Io, a little volcanic moon that's completely covered in new volcanic internal material that's constantly changing. Kind of looks like a breakfast pizza to me. All those little dark spots on the surface of Io are active volcanoes right now. And in fact, this picture of Io is probably a little bit out of date because those volcanoes have reshaped a bit of Io's surface. Another of Jupiter's lovers, a noblewoman named Europa, a very icy moon with a lot of hidden water beneath the ice. That hidden water is probably more water than the entire oceans of the Earth. And scientists think that it may contain alien life, as it's a protected ocean. It's very salty and warm, but protected from the dangers of radiation and space. Ganymede is named after the person that Zeus thought was the most beautiful person in the whole world. And it is a very pretty moon. It has these nice crystalline sharp edges, fissures created from the surface of Ganymede slowly changing over time, all these different ice structures and sort of spouts speckling the surface. Very strange little moon. Hopefully we'll get to see more of that over the next few years. And then finally, the furthest moon of the Galilean moons from Jupiter is called Callisto. And Callisto is one of the oldest surfaces in the solar system. All Callisto has done is collect craters. So it hasn't been changing on the surface like these other moons. There's no ice being created anew or moving around or cracking. It's just kind of a solid frozen surface speckled with craters. And Callisto is named after an unfortunate person who fell in, or Zeus fell in love with her. And Hera, Zeus's wife, found out, and so Hera turned Callisto into a bear. And this same bear is the bear in Ursa Major, also we know as the Big Dipper. Hera then tricked Ursa Major, or Callisto's son, into hunting her down with his bow. And so Zeus felt really bad for the pair of them, turned her son into a bear, and then threw them both into the night sky to become constellations. And here we can see a moon named after the mythological figure of Callisto. Now we can return to Earth because, of course, there's some actual real life connections for romance and space, because we've been sending people to space, and being people, they tend to have some sort of romantic entanglements and love lives. So some of the earliest astronauts from the Russian Space Agency, we have Tereshkova and Nikolaev from the Russian Space Agency. Tereshkova was the youngest woman to ever go into space at the age of 26, and Nikolaev was part of the earliest space programs, the cosmonauts. And after their training and their missions, they'd been together a lot through those trainings and fell in love and got married. We can also travel to some of the space stations around Earth, like the International Space Station. Some of the astronauts that have traveled to this International Space Station have been in romances. For instance, early in the space station or late in the shuttle period, there were a couple of astronauts that knew each other as astronauts, fell in love, got married, and didn't tell anybody until they went to space. So it's kind of against the rules to go to space with your spouse, as it can be kind of a problem if something goes wrong with that relationship in space and you're trapped with someone on a space station for months. But they got married before and they went up to space together, and yeah, they lived up there together for a little while doing a space shuttle mission. There's also astronauts Doug Hurley and Karen Nyberg. You might remember Doug from last year. He was one of the astronauts with Bob Behnken to go up on the Falcon 9 rocket aboard the Dragon space capsule. They were sort of testing out that capsule back in, I believe, July. They are both married, and they've both been on many shuttle missions and to the International Space Station. And they were asked, if NASA allowed it, would you go to space together? And they both gave a firm no, we will never go to space together. And at first it seems kind of like, oh, you don't want to be in space with your husband or your wife for months at a time, just locked in a spaceship. But the meaning for their answer is kind of heartwarming to me, because they have a son, and they both know that going to space is extremely dangerous. And so they knew that if they were to go to space together, they could be risking the lives of both of their son's parents. And they just didn't want to even chance that. So, they said they would never go to space together so that they would, kind of keep their family safer. But who knows, someday if going to space is a lot safer, maybe the whole family will get to go on a trip to the moon. All right. And then my last story of space and romance takes us back to the 1970s. So let's look at the solar system from above back in 1977. And here we can see our planetary orbits with the labels of the gas giants. And we look at this because if you were a space scientist back then, you might have noticed that Jupiter, Saturn, Uranus, and Neptune make a nice spiral around the solar system in 1977. And a spiral like this is perfect for sending out a spacecraft to all of those planets using their gravity to get a free booster to the next planet and then leaving the solar system. So that was the design of the Voyager spacecraft. And if we start from 1977 and just kind of zoom through the years, we can actually watch as they pass by Jupiter, go by Saturn. One of them continues into deep space, and one of them visits Uranus and Neptune, where we get our first and most recent pictures of Uranus and Neptune back in the late 80s and 1990s. And then they continue on into deep space. So if we back out, we can actually see the orbital paths of these spacecraft continuing away from our solar system. And they will continue to travel through our galaxy for the rest of time. Now, one must think, maybe there's alien life out there. Maybe they're close. And maybe that alien life finds one of these Voyager spacecraft. Do we want to tell them about humanity and Earth? And what do we want to tell them? And so scientists thought about this. They said, okay, if we include some information on this spacecraft, what's it going to look like? So let's fly to one of the Voyager's spacecraft. We're going to Voyager 1. We'll zoom in. And we'll kind of spin around until we see a golden record. Because these spacecraft carried a golden record with information about humanity. There it is. So this golden record looks a bit like this. It has two pieces. It has a plate of visual information showing things like our location in the galaxy, a little bit of our understanding of sounds and frequencies and numbers, a little bit down there about atomic physics, just very simple stuff to show, hey, we're technologically advanced a little bit. Here's what we know. We also included an actual record. Looks like a vinyl record made of gold, kind of like a master press. And this record contains all sorts of things. It's called The Sounds of Earth. It contains sounds of nature, of people talking in different languages, contains little bits of music that the scientists thought would be valuable representations of human music, like jazz and blues and rock and classical music. They recorded laughter, and they also recorded someone's brain waves. And before we talk about the brain waves, I want to introduce you to two people. That's Andromeda and Carl Sagan. So these two worked on the Voyager spacecraft, and they more specifically worked on these golden records. What do we want to share about humanity? And during their work, they both fell in love. And the person they recorded the brainwaves of is Andromeda on the left. Now, she recorded brainwaves and thoughts about anger and happiness, sadness, funny things she remembered, but she also thought about her love for Carl and falling in love with Carl. And these two went on to create some of the most phenomenal science education programs, TV programs out there. They've been a huge inspiration to thousands of scientists, both astronomers, biologists, chemists, and physicists. They've been a huge inspiration to me as a sharer of astronomy, as a planetarium operator. And they worked together very closely, and they were married until 1996 when Carl passed away. And since then, Andromeda has still been helping produce high quality astronomy education outreach programs to this day. And so I just love that they were such a power couple in science education, and then they got to participate in this amazing program of creating this golden record. And I love knowing that when I look out to the stars and I imagine all the cool stuff, all the mind-blowing stuff like galaxies colliding and stars exploding, I also love to know that out there on a little spacecraft on a golden record are recorded brainwaves of love. And I just love to know that out there in the stars, love is out there. So this is our Romance in the Stars program. Happy Valentine's Day to you. A happy belated Valentine's Day to you if you're seeing this later. Thank you so much for watching this part. It's not over. We're going to switch to a little bit of a night sky tour. We have a selected date from one of our viewers for their anniversary. So I'm going to switch over to our night sky tour software. This is a little more specific towards night sky tours. And I'm going to share the screen towards that. And what you should see in a moment is a blue sky and green grass. And this is the same view that we started with in Romance in the Stars. We're in Jackson. We're looking towards the south. There's the highest sun in the sky. And they requested the anniversary date of January 6th. So we're going to take a look at the sky on January 6th. Now, we're in February, so not much different from what you might see tonight. The sun's a little bit lower and it's going to set a little bit quicker. We'll jump through time and set the sun. We're going to get a sunset a little around 4 o'clock, 4:30, I should say. And you can start to see some of the stars in the sky on January 6th. If you look really high up in the sky after sunset, and you can still kind of see this now, there might be a bright reddish star high up there. And this is the planet Mars. If you're watching this after February 18th, hopefully the Perseverance rover has landed on Mars and it is doing safe up there. This planet is going to look kind of bright like a star, but the best way to tell the difference between a star and a planet is that planets don't twinkle. And this little red star-looking object high above us is the planet Mars. Now, just past Mars, you might recognize some things we've already seen. I'll move forward in the night just a little bit, and we can see our friend Orion, the hunter, rising in the east. You can spot Orion by his belt and his shoulder stars and leg stars. They're usually pretty bright and bright enough to see under most conditions, barring clouds. Next to him, we have Taurus the bull. And of course, next to Taurus, we have the Pleiades, my favorite thing in the whole night sky. You can see it with the naked eye, and you can also see it with a pair of binoculars really well. In fact, if you look at the Pleiades with a really good telescope, it might not look that interesting because you might look too close and you miss all the good details. So a pair of binoculars goes really far for the Pleiades. Just above Taurus and Orion, we have the star Capella, which makes up the constellation of Auriga. Auriga represents a charioteer and his pet goat, which is the Capella name that I mentioned. Below them, we have the Gemini twins, and then rising in the east after Orion, later at night, which is much easier to see now in February, we have the brightest star in the night sky named Sirius, which is part of the dog constellation, the big dog, and Procyon, which is part of the little dog, Canis Minor. So these are going to be kind of the bright groups of stars rising in the east and southeast through January, and they're still pretty high up right now. Let's take a look to the northern sky, and here you can start to see the Big Dipper rising in the northeast. This is the handle of the Big Dipper, and again, the Big Dipper is part of the constellation of Ursa Major that we know as Callisto. And so there she is thrown into the sky by her tail. The story says that it stretched out her tail, making it look like kind of like a weird bear with a long tail. And there's her son, the second little bear. And they kind of circle in the northern sky. If you're in the northern hemisphere, north of Michigan or more north, these two constellations never set below the horizon except for the legs of the bear. So they make a big circle in the sky around the North Star that I have targeted right now. Of course, just across from the big bear is Cassiopeia, the queen. And one of my favorite parts in the night sky is if you can find Cassiopeia and her daughter Andromeda right in between him, kind of where you see this chain around Andromeda's waist, is a little smudge. And that little smudge is the Andromeda galaxy. That is our closest galactic neighbor, and that someday the Milky Way and the Andromeda galaxy will have their own little romance where they merge together and they create a new galaxy, and along the way they'll create hundreds of billions of new stars. So you can see that in the sky with your own naked eye or a pair of binoculars under a dark enough sky. And it's 2.5 million light years away, meaning it takes 2.5 million years for the light to travel from Andromeda to Earth. So that's some of the sky on January 6th. Again, it's a little bit close to what you can see now in February. In fact, it'll look a little bit more like this in February now that I've kind of moved forward in the night. That's the thing too, is if you miss something in one season or it's up way too late, it'll always come back or it'll be easier to see in the next season. But that's a little bit of our night sky. I'm going to switch back and do a little bit of a universe tour, and then that'll be our show. So I'm going to change over to the universe tour. In this tour, we're going to kind of start from a view we've seen before, where we're looking at the whole solar system, and then we're going to sort of back away further and further until we're at the edge of the universe. And it's loading up right now. All right. So I'm going to share my screen one more time. Oops. Seeing all the details behind the scenes. There we go. And again, we're back here at the Earth. We're going to fly up above the solar system. This time we're here in the present, not 1977. Here are our planetary orbits now. These close-up rings to the sun are the terrestrial planets, Mercury, Venus, Earth, and Mars. We have our gas giant planets. And then out beyond Neptune, we have the Kuiper Belt. This is the icy ring of objects where Pluto lives. That includes other dwarf planets like Eris and Sedna. And the Kuiper Belt extends quite a ways beyond this, but this is where the major part of it is. It's sort of like an icy donut around the edge, frosted donut, if you will. Out beyond that, and in fact, we'll keep that up and get rid of the planetary orbits. Out beyond the Kuiper Belt, you can start to think about the Oort cloud. The Oort cloud is the big sort of sphere of comets that lives around the sun. So if you've heard of Halley's Comet or Comet Swift-Tuttle, all those different comets live way out on the edges of our solar system, nearly 1 trillion miles away from the sun. So pretty long distances. And of course, that means it takes them very long periods to actually come by the sun. Some of them have only passed by the sun a few times in the entire history of the solar system. But some of them, like Halley's Comet, come and visit us every 60 years. So it's a very periodic thing. And this is where they spend all their time when they're not in the solar system. We can back away to one of our nearest stars called Alpha Centauri. Alpha Centauri is about 4 light years away. So you can kind of get an idea of how big that Oort cloud is. It takes 4 years for the light to travel from Alpha Centauri to Earth. One I forgot to mention, but with the speed of light, if we're going to keep talking about that, I'll give you another reference point for the speed of light. It takes about 1 second for light to travel from the moon to the Earth. So you can always look at the moon and you're seeing the moon, what it looked like about 1 second ago. So when you think about a light year, you can kind of think of the distance of the moon times, a year. So here we have our label for the sun to kind of give us a reference point as we fly further away from our solar system. We're going to visit the star Sirius now that we saw in the night sky, the dog star in the dog constellation. Sirius is about 9 light years away. And if you know anybody named 9 or around 10, you can point them to this star and tell them the light they're seeing from that star right when you show them is from when they were born. We can also travel to the head of Taurus, because the head of Taurus is also a star cluster. It's this little group of stars right in front of us, and it'll help to see it if I get close to it and kind of wiggle it. You can see how there's a little bit more stars right there in front of us than there is everywhere else. And so this is the head of Taurus. And then we see it as a constellation about like this. You can almost see the V shape there if I hold it like that. Or kind of aim it right there. You can kind of see that V shape that we see in our night sky. We can go a little bit further back and see the Pleiades where they are in space. They're about twice as far away from the sun as Taurus's head. The Pleiades is made of very bright, big blue stars and dozens of little white stars and stars like our sun. But I always love seeing these clusters in space, what they look like from a 3D perspective. We can travel to a star in the Orion constellation, the bright shoulder of Orion named Betelgeuse. Betelgeuse is a really big star. If you took this star and you put it all the way over where our sun is, the edge of Betelgeuse would reach almost to the orbit of Jupiter. It would at least reach to the asteroid belt, and that is a couple 100 million miles away from us. So huge star. And someday, maybe in the next 100,000 years, Betelgeuse will explode in a beautiful supernova that will look as bright as the full moon in the daytime sky. We'll be totally safe from that, so no worries. But yeah, this is about 450 light years away from us. Pretty far. All right, so now we can just start zipping away from our local stellar neighborhood and leave the galaxy. And we can see our own Milky Way galaxy right here, a beautiful barred spiral disk galaxy. You can see these grand spiral arms of stars or forming new stars. You can see the central bright bulge of the galaxy. That is where a lot of the older stars of the galaxy live, and they make sort of a sphere in the center. And then out beyond our galaxy are just huge thousands and thousands of other galaxies throughout our local galactic neighborhood. We've been to one, we saw one in the night sky. This was called the Andromeda galaxy, and this neighbor to us is around 2.5 million light years away. We can see it from here, and we can actually kind of turn around and get a view of our Milky Way from the perspective of Andromeda. And again, over the next few billion years, our Milky Way and the Andromeda galaxy will collide together to make a new, bigger galaxy. So you can kind of see it over there in the right middle area. That's our Milky Way galaxy. We can go to a big cluster of galaxies. It's called a galaxy cluster. And this one is called the Virgo cluster because it lies in the constellation of Virgo. But this galaxy cluster is actually sort of the gravitational center of our local galactic neighborhood. All these thousands of red dots represent galaxies that live in the Virgo supercluster. And you can see clusters of galaxies that live around Virgo. And so those are all part of the Virgo supercluster of galaxies, almost like a major city of galaxies. And we in the Milky Way galaxy kind of live over out there in the rural area, away from the big city. And if we back away from this, we can actually start to see other kinds of big structures. Sometimes these are called galactic walls, and these are clusters or big formations of galaxy clusters. They are sometimes called filaments, where you can see they have a sort of webbed, stringy nature to them, and that's just sort of how galaxy clusters physically collapse in the universe and clumped together. And you can see quite a lot of detail in our local galactic neighborhood. And so all these galaxies in this box are sort of local to us. And if we extend beyond that, I'll make sure we're pointing at our solar system. So we shifted just a bit to look at home. We can fly beyond this to see the galaxies discovered in galactic surveys. So these are telescopes that look at huge chunks of the sky for years, and they count as many galaxies as they can. Now, the reason they look like these butterfly wings or these wedges is because they can only look at so much of the sky at the same time. And our Milky Way galaxy also blocks a little bit of the sky from us, and that's why it's sort of cut in half right down here in the middle. This is the 2-degree square field survey. There's the Sloan Digital Sky Survey, which observed for over 5 years, and they counted all these galaxies. But they also counted some of the galaxies from the beginning of the universe, called quasars. So these were the early galaxies. They were really, really bright, and they actually look like stars today. They're just extremely far away. And we can see these mapped out in the thousands. Over the next few years, even more survey telescopes will come online and count even more galaxies. The Vera Rubin Observatory, which will begin hopefully in the next couple of years, will take an entire picture of the southern night sky every 3 days, and it will do that again for 5 years straight. Every 3 days, a new picture, counting more and more galaxies and seeing more and more of the universe. So looking forward to stuff like that. If we back out a little bit more, we can actually see the cosmic microwave background radiation. This is the earliest light from nearly the beginning of the universe. When the universe was very young, it was very cloudy, and it would be like just not being able to see anything through the fog. But eventually, the universe cooled down enough that the light could stream freely. And scientists analyzed this light for little differences, little bumps and wiggles. And you can see these little bumps and wiggles as the red, yellow, green, and blue light in this bubble, this sort of giant spherical picture of light. And these little bumps and wiggles eventually became the galaxy clusters and the galaxies that we are looking at in the center. So it's sort of like a historic map of the universe. This is called WMAP. It's one from the 2000s. There's a newer one called the Planck survey, which has higher resolution, so you can see more of the bumps and wiggles and the big structures. And then what I love to do from here is to dive back through all those galaxies observed, the quasars, back into our local galactic neighborhood, back into our galaxy, back into our local stellar neighborhood, and then back to our little home solar system, the sun and our planets and the Earth. So that's our universe tour in a nutshell. Thank you for joining us for this virtual Romance in the Stars. I hope you enjoyed it. If you have any questions, you can email us at the museum or call. and we hope you enjoy this program. Have a good day.